Okay, so this is the first of several videos about a topic called significant figures. Significant figures, I'm not talking about influential people in history. This is a science or a math term. Significant figures is a measurement that includes all digits that can be known accurately plus a last digit that is estimated. Like right now, it's hot. What temperature is it? I don't know. In my room, it's probably 73 degrees right now. Do I have a thermometer in front of me? No. I know it's not 80 something. It's not that hot in here. And it's definitely not in the 60s. It's in the low 70s. My guess, 73. That number 73 is a significant figure because I know it's in the 70s. The last digit 3, is it 73 or is it 74 or is it 72? I don't know. I'm just estimating. There would be two significant digits or significant figures. In fact, sometimes you hear significant digits, significant figures, same kind of thing. But there's two significant figures in the number 73, if it's 73 degrees in my room right now. Okay, so that's what significant figures are. We're going to look at a few other things, like we're on measure here. Assume we want to know how much water are in each of these cylinders. We'll start cylinder 1. Don't look at the other ones right now. Okay, this is based on just that figure in front of you. Okay, these are all 4 different questions. If I want to know how much water is in this picture, it's like, well, obviously that says 1,000, and the bottom we're assuming to be 0. Just a reminder, how we read this thing is always going to be a curve. If this is a granulated cylinder, as it says it is, we always read it based on the lowest point or you can say the vertex of this parabola, called a meniscus. Either way, it's about halfway. I don't know, maybe 500 milliliters is probably what I would write. And I can't write on this screen, but I don't think I can write on this screen. Maybe I can. 500 milliliters. Okay, no, I can't write on the screen because I can't figure it out. Whatever, 500 milliliters. I'm going to ruin this if I write more. Okay, so 500 milliliters is the volume, is what I'd say for this. And if I wrote 500, the number 5500, that number would have one significant figure. I'm even guessing it's around 500. It really could be 400 in this picture, maybe 600, but I think it's about halfway. I'm going to estimate 500. That's one significant figure. Now, let's get cylinder number 2. How much water is in the cylinder? Well, there's 300, there's 400, that's 500. The line above is 600. Now, this is between 500 and 600. So it's not 500. It's more than 500. And it's obviously less than 600. Remember, we're reading at the vertex. It's more than 500, less than 600. Maybe halfway between. How about 550? Okay, it's not 580. It's not 520. It's more in between 500 and 600. I'd say maybe, 550. If I wrote 550, that number would have two significant figures. The two fives. I really don't know if this is 551.7. All I know is about 550. Okay. Look at figure 3. This picture right here. Okay, again, we're trying to read how much water is in here. The bottom, the vertex of that parabola. It's somewhere between 550 and 560. It's not equal to 550, nor is it equal to 560. It's about halfway between 550 and 560 in that diagram. I would say there's probably 555 milliliters of water in there. That number 555 has 3 significant figures, 3 digits, 555. That would be 3 significant figures in that number, 555 milliliters. Cylinder 4. How much water is in this picture here? Well, somewhere between 555 and 556. About halfway-ish between 555 and 556. So how about 555.5 milliliters? And if I wrote 555.5, that number would have 4 significant figures. There are 4 digits in that number. So that's kind of a bit about significant figures. All the numbers that we know accurately, plus the last digit that we're kind of estimating. Could I say back to figure 1 that there's 555.5 milliliters? How in the world, based on just this diagram, could you tell there's 555.5 milliliters? You can't do that. I'm already guesstimating there's around just 500 in this one. No way could you do that. Like, what's the temperature in this room? I said it's around 73. Could it really be 73.1829? Could be. I don't know. I'm not a human thermometer. Could be. Maybe. But I'm just 70, low 70, 73 somewhere is the temperature in my room right now. I had the air conditioning on, so that's why it's around that. But I don't know exactly what it is. Okay. I'm going to read how long this line is. This line is measured against ruler 1, ruler 2, ruler 3. Just look at ruler number 1 right now. And if I look at ruler number 1 right now, I'd see, well, that's 4 centimeters. 2 is about here. I don't know. I'm trying to pretend that I don't see that middle ruler. It's less than 2, more than 1-ish. 1.5 is probably what I'd say. Okay, 1.5 centimeters. Looking at this second one, though, okay, 1.5 I would say is 2. Oh, that's 2 significant figures. This is it 1.5 according to this one? No, it's more than halfway. I can tell that. Halfway would be where around this arrow or my cursor is. Tip of that. A little bit more than halfway. I don't know, 1.6 centimeters-ish. That's still 2 significant figures. 1.6, there's only 2 digits in that. Now let's look at the bottom. I don't know how to get rid of that, so maybe hit exit. Or, oh, I should not have hit exit. Okay, well, I can still see this. This picture there, it says it's more than 1, 2, 3, 4, 5. It is at 1.6. Is it 1.62, 1.61, 1.5? No, I pretty much say it's on the line, almost. I'd say this is 1.60 centimeters. And if I say that's 1.60 centimeters, then this thing here would be, this thing right there would be 3 significant figures. And let me see if I can show this back again to present from that slide. Okay, I'm going to pause for right now. Okay, sorry, back. I don't know what I pushed earlier. Okay, so yeah, from that bottom picture, I'd say that dashed line, it's pretty much on the line, and because of that, I'd say it's 1.60 centimeters long. Okay, going on. How much water is here? 40. That's 50, between 40 and 50. I'm looking at that. It's more than halfway, 46. 46, whatever the units are, let's say milliliters. So maybe 46-ish units. This one, again, we read at the meniscus, so at the vertex. That'll be right here. If this is 35 and that's 40, this would be 36. Is between 36 and 37. So 36 and a half, maybe? 36.5. 36.5 would be 3 significant figures. 36.5. 365. There's 3 digits or 3 significant figures in that number. Here, if I want to read this, okay, another trick question. Notice here, this is 20 and that here's 21. So this would be 20.1, 20.2, 20.3, 20.4. It's between 20.3 and 20.4. So 20.1, 2, 3, 20.38 ish. Okay. So these are just, when we're estimating, we're always estimating the last digit. So that's one thing that we have to do with in terms of reading these numbers, significant figures. There's going to be 5 rules. I'm going to do this in a different way later on, but this is just the first of significant figure notes. There are 5 rules about significant figures. First rule is Every non-zero digit in a recorded measurement is significant. So numbers 56.8, 967, 0.735 have all three significant figures. Obviously, three digits, three non-zero digits, three non-zero digits. 0 here is not considered significant. We're going to get to that because it's only rule 1 of 5. So 3 sig figs, 3 digits here, 7, 3, 5, 3 significant figures there. That's rule 1. Rule number 2 of 5. Zeros appearing, in fact, let me go back. All the other rules are based about zeros, okay? So if it's not a 0, it's significant. All the rest are what if there's a 0. Zeros appearing between non-zero digits are significant. 40005 has 5 significant digits or significant figures. Again, I'll use sig figs, significant digits interchangeably sometimes. This has 1, 2, 3, 4, 5 digits in it. These zeros are significant because it's between a 4 and a 5, which are non-zero digits. This number has 3 significant digits or significant figures, sig figs for short, zeros between a 5 and a 7. This 0 is significant because it's between a 2 and a 9. This 0 is significant because it's between an 8 and a 4, making every number in that, every single digit there significant. There will be 6 sig figs or significant figures. Rule 3. Zeros in front of all non-zero digits are not significant. The 0 in front is not by definition significant. This number here, 0.9837, has 4 sig figs. This number here has 3 significant figures. This number here, 0.000084, 2 sig figs. Zeros in front of number do not count. This number here has only 3 significant figures. Zeros in front of non-zero digits, all zeros in front of non-zero digits are not significant. Another way to see it is if this were written in scientific notation, this would be 4.78 times 10 to the 1, 2, 3, 4, 5 to the minus 5. 4.78 is only 3 significant figures. So zeros in front of number are not by definition significant. Rule 4 or 5. Zeros at the end of a number and to the right decimal point are significant. 76.00, 4 sig figs. 5.084, 4 sig figs. 4.000, 4 sig figs. If it's to the right of the decimal, you see the decimal point here? It's to the right of the decimal point and the end of number, it is by definition a significant figure. If I weighed an object, if I bought 4 pounds of grapes at the grocery store and it read on a scale 4.000 pounds, well, it didn't say 4.0001, it said 4.0000. All those numbers are significant. They do count. Rule 5 of 5. Zeros at the end of a measurement and to the left of the decimal point can either be significant or not depending on how it's measured. Example, 300, 2900, 510. So actually for this, if it ends in 0 but before the decimal point, we're going to probably assume the least. I'd say this is 1 sig fig, 2 sig fig, 2 sig fig. But you don't really know. So to avoid the unknown, measurements should be written in scientific notation. Like 4.90, that's 3 sig figs. It's at the end, behind the decimal point. If it's before the decimal point, we're not sure, but behind the decimal point and to the right of the decimal point, we do know what it is, that it is significant. So if you're not sure, they really should be written in scientific notation. But if I was given a number 300 or that, I would just probably say the least or 1 significant figure, the least or 2. But it could be 3, it could be 4. This, I would say there's 2, but it theoretically could be 3. But if you don't know, we usually assume the least. Okay, let's figure out how many sig figs in these numbers based on these rules. First number, 145, 3 digits. This number here, 0.274, 3 digits. This number here, 5 significant figures. Because 0 is between a 4 and a 3, and that 0 is between a 3 and an 8. Zeros between non-zero digits are significant. Oh, and the one I just said here, this is 3 sig figs, because zeros in the beginning of a number are not significant. Here, whenever you have scientific notation, pretty much ignore the times 10 to the whatever. Look at just the 9.700. Whenever you have scientific notation, just look at the front part, the coefficient part. So this number here is 4 sig figs because zeros at the end of number and to the right decimal point. It has to be and. So at the end of number and to the right decimal point are significant. This is 4 sig figs. This number, well, same rule. End of the number and to the right decimal point, 4 sig figs. This is 2 sig figs. Why? Zeros in the beginning of a number are not considered significant. Hey, these zeros do not count in terms of number sig figs. But that 0 does. This number is 3 sig figs. And the last one is 4 sig figs because zeros at the end of the number and to the right decimal point. Has to be to the right number and decimal point here. So right of the decimal point and at the end of the number are significant. So 76.00 is 4 significant figures.